Welcome back to today's session. In this session, we'll see about LTE frequency hopping. Okay. Before we go into the hopping technique, this is a cellular architecture of wireless technology in which the communication will be through cells. Means each user entity will be coming in a cell and the service will be provided through the cell. Each cell will be composed of BS, that is a base stations, in which let us take an example. Okay, if the user is in a cell number BS0, okay, means call is established. If user is in roaming, means the frequency in which is capturing from BS0. Okay, as the user is moving towards one of the cell, the corresponding frequency will be getting changed. That is what we call a frequency hopping. Means if the person will be go from BS0 to BS4, the still the communication is in process, but the frequency will be changed. That is, it will be catching with the frequency BS4. And similarly, if the user is moved to the one more station BS8, again the frequency will be changing to the 8. Means the if the user is moving around this cell, the frequency will be getting changed. That is what we call a frequency hopping. Okay, in which since it is to speed up the transmission rate for a narrow band data signal and results in a wideband transmission. Okay, now this is what a cellular architecture will be supported in wireless communication. This is a brief introduction. It is required to know what you mean by hopping techniques. Okay, now when I come to the point of hopping, okay, that is a spread spectrum techniques are generally broken into two quite different categories, that is direct sequence and frequency hopping. Okay, the very first one is a direct sequence spread spectrum. It is supported into CDMA, in which it is widely used in a cellular voice network. And in a multiplexing, a large number of variable rate users in a cellular environment, frequency hopping is used. In some low rate wireless LANs, Bluetooth, okay, to avoid or to minimize the average interference ratio that will be in GSM cellular networks. Similarly, the job of resource hop, there is a frequency hopping, okay, is to resource mapper maps the complex valued modulation symbols in a sequence to the physical resource blocks assigned for transmission of PU-SCH. Okay. Therefore, in LTE, only localized resource allocation is supported in uplink due to its robustness to frequency offsets compared to distributed resource allocations. Okay, means when the communication is through the uplink and the downlink, only the localized resources will be allocated, okay, to retain a single carrier property in the uplink transmissions. That is, usually on the contrary of the downlink, it is possible to allocate disjoint sets of resource blocks to the user entity to extract some frequency gain. Means as we told, okay, it will be like a communication will be from the user entity to the BS. There is a base station, from base station to the user entity, in which the contrary, in which how the resources will be allocated and disjoint. Okay, that is, to alleviate this issue, LTE supports frequency hopping in PU-SCH, which provides additional frequency for the communicative purpose. Okay, and also, okay, the frequency hopping is for diversity gain in uplink. That is, frequency hopping can also provide interference averaging when the system is not 100% loaded. That is, LTE has intra-subframe and inter-subframe frequency hopping. Okay, as we'll discuss in the next slide. Okay, that is what, okay, how it will be supported. That is inter-subframe and intra-subframe. Okay, as you can see, this will be arranged in the form of like a blocks. Okay, that will be like intra-subframe hopping. Okay, like you can consider, okay, the user will be moving, okay, from the horizontally, vertically, or in diagonally. Okay, that is a hopping the user. Okay, in intra-subframe hopping, the user entity hops to another frequency allocation from one slot to another within the same subframe. Okay, that is, okay, user will be hopping, that is like what I say, the change of frequency, okay, within the one slot only. Okay, like how it will be considered, because when we take a cellular architecture, there is a sectored, okay, the cell will be again divided into subcells, okay, to increase the number of user entity, to increase the number of user to support high rate. Okay, since, okay, within that also, if it is changing, it is called intra subframe. Okay, in inter subframe hopping, the frequency allocation changes from one subframe to another. That is, higher layers determine if the hopping is inter subframe or intra subframe. Okay, now when in the previous first slide, if I took here, let us consider there's a one cell in which, okay, if I divide the cell into like a 6 cells, 6 again subdivision. Okay, the user is in a one cell. Okay, again it is divided into sub frequency. Okay, if the user is moving around all the cell, all the frequency, okay, it is a intra. If the user is moving from one cell to another cell, okay, that is an inter subframe. Okay, there is a frequency will be changing here. That is what higher layers will decide if the frequency is intra subframe or inter subframe. Okay, in general, okay, if I say in general, the intra subframe hopping provides higher frequency diversity gain, since this gain can be extracted over a HARQ transmission, which always spans only one subframe in case of inter subframe. Okay, that is what. Okay, now the when it will decides, okay, if the single bit of frequency hopping FH, okay, if FH field in the corresponding PDCCH in the channel of a PDCCH with a DCA format is 0 or set to 1, okay, it will perform, okay, whether the frequency hopping or whether to be performed or not to perform. Okay, now how it will be decided? Okay, look at this. If FH is equal to 0, no frequency hopping, that is uplink frequency is disabled. Means, okay, if, okay, each cell will be indicating, each cell, if there is like a FH in the PDCCH, indicating whether to perform hopping or not to perform hopping. If FH is equal to 1, frequency hopping in uplink is enabled. Okay, I hope you can understand. Uplink in the sense means user entity, okay, when it is connected to the BTS uplink direction, okay, hopping can be changed. Means there is a cell to cell, okay, from one frequency another frequency is possible, that is enabled. Okay, the next one, okay, uplink control that is information. Okay, what is the role of uplink control information? Okay, it assists in physical layer and provides a following types of information. That is a DQI, okay, it is used to assist adaptive modulation and coding and channel dependent scheduling of the downlink transmission. Okay, that is CQI indicates the highest modulation and coding rate that can be supported in the downlink with a 10% block error rate on the HRAQ transmission. Okay, similarly HRAQ, okay, it's an acknowledgement, that is like a acknowledgement, okay, with the ARQ or ACK associated with the downlink for the process operation. Okay, based on the content, this is the content of uplink control information. Okay, similarly, scheduling requests, okay, there is a SR for radio resources for the uplink transmission. Also, the pre-coding matrix indicator PMI and the rank indicator RI for the downlink MIMO transmission, okay, in which RI indicates a maximum number of layers that can be used for special multiplexing in the downlink, while the PMI indicates the preferred pre-coding matrix. Okay, there is a cyclics and prefix as we discussed in the previous class. Okay, that's what when I say the channel mapping, okay, with the uplink control information, when the data will be providing from uplink control information, it has to be properly mapped so that the information will be transferred from one layer to another layer, okay, during hopping techniques. Unlike the hopping, okay, for control information in the uplink, okay, as you can see here, okay, there is a control information in the uplink. You can see here control, there is a two layers, control information CIQ, physical channels. Okay, in the physical channels PUCCH, PUSC, they are mapped to the UCI, control information channels. Okay, in which uplink and the downlink, which has three different physical control channels. There is only one physical control channels, there is a UCI, okay, in which it will be controlling two channels here. Okay, means then like when I say, okay, UCI, the PUCCH, the UCI can also be mapped to the PUSCH when the user entity has been assigned uplink radio resources. When this happens, the UCI is frequency multiplexed with the ULSCH data on the PUSCH until the PUSCH channel carries a random access response for a grant or a retransmission. Okay, these are like a channel to be carried out in the physical layer, okay, for the mapping purpose, okay, in which the physical layer procedures related to UCI transmission, there's a CQI and PMI rate indicators. Okay, as you can see here, okay, the mapping will be from user entity. There is a user entity in which assigned in the uplink radio directions. Okay, in recently we are most used with the CQI, in which channel quality indicator. Okay, now what is the job of this one? Okay, in the MIMO, okay, there's a MIMO mode. Mainly it will affects the operation at E node P, means it will affecting to the base station, okay, in the LTE system. Okay, that is how we calculation and scheduling process will change due to interaction between data streams for different user entity. That is what E node P can estimate the channel information from the uplink reference signal. Okay, that is why CQI calculation and scheduling without further feedback from the user entity. Okay, that is what it will indicate a channel quality. Okay, well, let us take that how it will decide. Okay, let us take the if the user has been caught with a one traffic data channel in which it will be communicating. Okay, now if it finds there is a hopping, okay, hopping without any call drop, okay, how fast it will hand over, okay, to the another channel with another frequency, so that still the communication will be in the process. Okay, it will decide a quality indication. Okay, that is what it will be more perform or a more operation has been taken care with a MIMO, okay, in which it will be provided in the uplink as well as in the downlink. Similarly, if I say if I want to discuss in the downlink, which is used for adaptive modulation, okay, with a QAM or QPSK, okay, it indicates a highest modulation you require it. Okay, there is what like 100, there is a 10% block error rate on the HRAQ. It is required for the transmission of the data informations. Okay, this is what about the UCI, okay, and how it will be mapped, okay, the corresponding channels from control information to the physical layer. I hope you can understand this one. Okay, thank you.